to relax it. Will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow before it's too hard. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard to follow before it's too hard. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back at it again. Another day here in the 100 Days of Rootkit. We'll fix this a little bit. There we go. We're chugging along. We're on a new chapter, alright? A new chapter of our dev lives, alright? This chapter is going to be expansion. Alright, expansion. We're starting from the beginning again. Don't worry. It's not going to break your brain. We're starting from the beginning again, a new language. This is for multiple reasons, alright? Reason number 1, get exposure to another language. Reason number 2, showing you how all programming languages are pretty much the same. Number 3, so we can show and be closer to a low-level language, so we can show and see low-level concepts, because they are used in every programming language. You just may or may not be able to easily access them. Alright? And the other reason, it's a compiled language, which is different than what Python is, which is a scripting or interpreted language. JavaScript, one of the most famous languages besides Python, is the same way. It's an interpreted language, all right? It's not compiled. So this is completely different. It's going to be a different experience for you, and it's going to be great exposure. Does not mean you have to do this language for your test, all right? Does not mean you need to learn this language, be a pro at it, all right? It's just exposure. But before we get more exposure to it, let's just talk about us for a second. If you don't know, we are Rootkit nonprofit here in the US of A. We're teaching for 100 days straight how to get our comp sci cert, which is a complete alternative to a college degree. No, you don't need to go to college, all right? You don't need to go to any other boot camp, all right? Boot camps compared to us, they're laughable. They're not even comparable. We're in a different level, all right? Just watch this. Train up, get everything you need to do, and take your cert, all right? On top of all this free stuff we're doing, if you go over to our blog, we have our week 9 giveaway up and active. Just go over there and enter to win a mystery gift. Enter to win a mystery gift. I forgot to push this out on the Discord, so I'll have to do that after the stream. It's very easy, and it's free. Just click this green button, put in your email, and then you just got to prove that you're subscribed to our YouTube channel, following our Twitch, etc., etc. Alrighty. Let us see here. If you like what we're doing, because doing things for free is a little pricey, there are links in the description and on Twitch in our About somewhere, where you can donate, all right? And all donations are being matched 1-for-1 for the first 10,000 donations. Depending on how much you donate, you can unlock epic rewards, like our stickers, our collab t-shirt, and this epic 100 Days of Rootkit sweater. It even has the Rootkit logo on the back. Look how epic this thing, all right? How epic this thing is, all right? We're hitting pillars along the way, like streaming for 24 hours straight, shaving my head here live on stream, and shaving my beard, which no one wants to see, all right? So we're probably not going to reach that goal, and that's okay. That's what we want. That's the real goal. The goal is not to reach our goals, all right? All right, perfect. Awesome. So, yesterday and on Friday, gave you guys some little taskies. Also on the Discord, pushed out information for you guys to install and get your VS Code ready. Found a little hiccup. Apparently they removed C++ from VS Code on macOS, so that can be resolved by using Xcode instead. Now, if you didn't install Xcode because it was pushed a little bit at the last minute, all right, it was pushed a little bit at the last minute, instead for today, you can go and start installing Xcode. It takes a little bit, I'm gonna be honest, all right? While it's installing, you can follow us on Replit, right? You can follow us on Replit. They will allow you to program in C, all right? You just create and then find C and then give it whatever title, and you can follow along on here, all right? We're not going to do anything that you wouldn't be able to do on this, all right? I'll go ahead and put that link into the chat. You most likely will have to make an account on those. All right, sweet. Any questions so far before we move on? Yep, I did just drop the link in the chat and on not just the chat on here, but also in the Discord. All right, sweet. So, for those who have Visual Studio or Xcode ready, go ahead and open it, and you're gonna make a new project. First, for people in Visual Studio, you can go and click on Create a New Project. All right, and you're gonna see right here, there's gonna be a little drop down called All Languages, or it might be one of these languages. Click on that, and then change it to C++. All right, C++. And then there's going to be one called Console App. All right, Console App. This is what we want to create. So click on that. You can double click on it, or you can click on it once and then click on Next down here. And then you're going to give it a name. All right, let's go Intro to C. All right, you can name it whatever you want. You can have it at whatever location you want. Totally up to you. Just go ahead and, create that. For people that are going to be on Mac OS, give me like 2 seconds to pull. Your steps are pretty much the same for Xcode. Give me like 2 seconds to pull this up. It's not going to show on stream, but you're going to want to, here we go. You want to create a new project, all right? You want to create a new project. So when you open it up, create a new project. It's going to ask you for templates that you want to follow. I don't even know. There you go. It's going to ask you for templates you want to follow like this. At the very top here, you can specify multi-platform, iOS, macOS, watchOS, blah, 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 all the different things they have. You're on a laptop, which is running macOS. So click on macOS. You will have something that is called the command line tool. Let me click on it once. So it's highlighted. I don't know. The command line tool. It's that little graphic there. All right. Command line tool. Go ahead and click on that. Click on next. You're going to give it a product name. You also have to give it an organization identifier. And there's a little drop down below that. All right. There's a little drop down below that. Oh, there we go. This is great screen share action. Click on C++. Click on that drop down and click on C++. All right. Give it a project name and then give it an organization identifier. What that is, get your name. All right. Your name will work just fine. And then click on next, and then it should automatically, we'll ask you if you want to save it somewhere. Go and save it and create it, and then you'll be all ready for us. When you're in Xcode, there's a little F5 is the universal thing for running your stuff. So press F5, or there's a little play button up at the top. If you can't find the play button up at the top left side, we got bigger issues. All right. For the Mac OS people, I'm gonna believe in you. All right, you can follow along just fine. We're not doing anything specific to Linux or Windows in these upcoming days. All right, so you should be able to follow just fine. And the interface on Xcode is arguably better than it is on Visual Studio. So you shouldn't have any interface issues. If you do, we gotta talk. All right, we gotta sit down a little bit, have a one-on-one, a heart-to-heart. So let me see first if I can zoom in a little bit into this because it's so zoomed out. Where is my test tools windows? Maybe it's in view. Probably is in view, right? Where is toolbar full screen? Now, come on. And this, of course, doesn't work. Oh wait. Okay, maybe this will work. There we go. We can do that. All right. Is that good enough for you guys, or do I need to zoom in a little bit more? I think it just goes straight to 400. All right, we're doing 200 then. All right. So by default, in VS Code, you'll get all these comments generated. All right. Comments in C/C++ are going to be with double lines. And yes, everything we've made so far has been with C++, and I keep mentioning that we're programming in C. Might be a little bit of confusion there. Don't be confused. C is the OG language. All right, C++ is the OG language. with some extra features. All right, you know how everyone is trying to sell products now, like, and throw a plus at the end of it. All right, C++ was the OG version of it. All right, why plus? Because plus is the auto incrementer in C. What does that mean? You'll see here in a second. All right, it's not in Python. All right, I wish it was. It's not in Python, so we'll see it here. For Replit, so we do C++. You can do C++ or C on Replit. Both will work. Both will work because pretty much anything in C will work in C++ because C is pretty much C++ is C with additional features, specifically object-oriented programming. But we're not going to be talking about C++ unique features. We're going to be talking about C, all right? And then from there, you can go adventure as you want if you want to get more into C++. What is C++ great for? It's a compiled language that will bring your code as close as possible to when it's compiled to good high-end machine code, all right? Good high-end machine code. It's extremely fast and efficient. It's one of the fastest languages in the world, all right? C and C++, all right? Rust can outperform it depending on the situation, according to some benchmarks that are available online. But pretty much no other high-level language will be able to outperform C. All right. By high-level language, I'm meaning it in the universal sense, as low-level is typically referred to as assembly. All right. The only way you can get faster performance is utilizing assembly, but the compilers are so great nowadays. Honestly, you'll most likely make less efficient code if you're in assembly than utilizing the compiler to generate the code for you. What is this concept of a compiler? Great question. This is compiled code, which means it goes through a process, all right? Python, we press play and it just runs, all right? It just runs because it is read in like a book, all right? It's read in like a book, like how you and me read a book. Compiled languages like C and C++ do not do that. They must first be compiled by a compiler, which means they are first taken. It's kind of like a translator. They're first taken, shoved into a translator. This translator will read everything, translate it, turn it into binary, and then put it on or save it somewhere. All right. And then you must go through the second extra step of then executing that compiled code. Additionally, depending on how you made your application, in C and C++, it's not universal. What does that mean? It will not work on all operating systems. All right, it will not work on all operating systems. If I make an application on Windows and I compile it for Windows, it will not work on Mac OS or Linux, and vice versa. If I make something on Mac OS, it most likely will not work on Linux, and it will definitely not work on Windows. And for Linux to Mac OS, it might work, it might not work. All right, it's kind of, you're playing a dangerous game. Why? Because when you compile, it's going based off of a bunch of unique identifiers of your CPU in your computer, and it's based off your CPU and your operating system, right? Because that will be interpreting everything. First, your CPU, because whatever commands are available at your CPU, at the CPU level, which are issued by the CPU manufacturer, and you won't really deal with those too much, those are going to be different for every manufacturer, all right? And then secondly, your operating system, because your kernel is potentially different based off the operating system you're on, and your kernel will handle different commands differently. And depending even on the operating system you're on, it may not even work straight up, all right? So older versions of Mac OS are not compatible with some of the newer versions or some of the features, and same thing with Windows, all right? So it's very, very picky, unlike Python, where if you write Python code, it's gonna run perfectly on everything right out of the gate. Asterisks, all right? Asterisks, of course, because everything in programming just depends. What it depends on that is if you were using some low-level libraries like machine learning, they have underlying C code built into them that will not work on every operating system right off the bat. But in general, Python code will work anywhere that you run it. JavaScript code will work anywhere when you run it, because it's a interpreted language. It has a bunch of stuff on top. The reason why languages like Java became so popular, which is different than JavaScript, right? Java is different than JavaScript, right? Completely different languages. They just happen to have the same name. It's like saying Mr. Smith here is related to the Smithsonian. No, they're completely different, just they have a part of their name that is shared. Java was the answer, the savior of all developers. It was Jesus Christ himself reincarnated when it first came around, because it was cancerous, it was annoying, it was hell to have to make applications and then recompile them for all these different operating systems. But not only that, some operating systems didn't have the same commands available, so you would have to change your code base a little bit based off the operating system, and whole chaos you've never experienced before. All right, Java came and solved that, because instead Java has this thing called the JVM, which is basically almost making it almost like a scripting language. All right, not quite, but almost like a scripting language. It's its own way to compile down code into binary, but it's a special type of binary that must be read by a middleman and then can work on any computer. All right, can work on any computer through the middleman. All right, so it was a godsend. Anyone could write code once and have it work everywhere. It was a huge money saver, a time saver, etc., etc., etc. The thing is, Java is slower, all right? Because if you have a middleman, it's going to be slower, all right? You don't get luxury features without introducing speed issues, all right? So Java has been outperformed, and through the decades, people have been on the hunt for a good Java alternative, and it has came. Mostly with the evolution of web, all right? There is no need anymore for the slowness and universalness of Java, all right? Because with the domination of web and web platforms, everyone's going to web-based platforms. JavaScript, conveniently enough, is the new universal language. When I want to make an app that works everywhere, I make a website that is mobile compatible, and I can now launch that app on any browser, which every browser is on every operating system, which now is on every phone. All right, it's everywhere at once, immediately. So JavaScript, conveniently enough, is beating Java. Even though they have no relationship to each other, they're competing with each other technically right now. And backend developers who were developing in Java are moving away from it. They are dying off, and they are moving to other languages like Golang, Rust, and C++. Because even though sometimes it can be locking you into a certain operating system or vendor type, it's worth it because you're usually only building server applications, and those server applications will be Dockerized, or they'll be for one operating system and one operating system only. So the speed benefits outweigh the being able to move it around, right? Because you don't need to do that. You just need it to work really well on the servers, which most servers are in Linux. So they're developing all this software to work in Linux. All right. C/C++ is everywhere. It's used for everything. It is what created the world as you know it. All operating systems are built in it. All right. C++ specifically is used everywhere in game engines like the Unreal Engine, or yeah, it's called Unreal Engine now, right? Sorry, I didn't look at the comments here. Yeah, we are learning C++ now. It's used in things like the Unreal Engine, which you can tell compared to Unity, Unreal is a little bit has a step up on its graphics game. Why? Because it's in C++, one of the fastest languages you can run on your computer, or use to then run on your computer. It's not a coincidence. Dot or C# is really, really good also, and really, really fast. So it's kind of the language, kind of the people behind the engine. All right, it's not just totally the language's fault, but you know, it runs some of the world's most powerful things. Additionally, machine learning is all done in C++. Now, you can write Python in it, and technically most of it's done in Python, but all those Python libraries you're dealing with were written in C++. All NVIDIA drivers are going to be C++ based, all right? You utilize the C++ libraries for NVIDIA, and that's how you mess with your graphics card. You mess with pretty much everything. C++ kind of silently rules the world, all right? There are some great reasons to learn C++, and there's great reasons not to even mess with C++ ever. It's not needed for a lot of jobs, all right? It's a very niche market, all right? Very niche market. It's very useful and very important, but it is getting more and more niche, all right? Niche doesn't mean not important, all right? It just means it's going to be small. It's its own little thing, its own little click on the side. If you want to be mainstream, everyone's using Python. So let's get into C a little bit. Now, C was the first, all right? C++ was version 2.0, all right? 2.0. They conveniently work well with each other. They are backwards compatible. By default, when you generate a project inside of Visual Studio or on your on Xcode, you're going to get a printout here that's going to be C++, all right? C++. If you click on the play button here, you're going to have two different play buttons here in VS Code. On Xcode, you're only going to have one. It's going to be a slightly long process for it to run, all right? So go and click on either the local debugger or the small one without the debugger. It does not matter. When you run that, you're going to see this thing pop up at the bottom. Please tell me I can make this bigger. You all are going to have to deal with that small size. All right. You're going to get this thing at the bottom. What it's doing there is it's compiling your program, right? It's compiling your application. It's taking this code that you wrote. It's going to then transform it into binary. Then it's going to have that binary get saved, as you can see on your terminal that pops up. This was called intro to C.exe. So it's a compiled exe program, all right? And then it will run this program automatically for you, all right? And if we want to change anything, we have to recompile it from scratch all over again, all right? So it can become a very, very long process, all right? Compiling can become very, very long and very, very slow. So, as you can see, this program was a simple hello world program, all right? Simple hello world program. This is your object-oriented code, all right? Your object-oriented code. May look a little bit more cancerous than Python, because it is, but it works functionally the same way. You know how in Python we can say stuff like, I don't know, my string dot, I don't know, what was, like, replace, all right? This dot part that we could do before, or maybe it was like your class, you know, class dot replace, basically the same thing you can do here, but they have double colons instead. It's a little bit more than that, because they also have a concept called namespace, etc., etc. We're not going to get into C++ too much, but effectively this is saying the standard library, and inside there you want to output, right? You want to output some text, and this is how you go about outputting text. For now, you can just delete this whole entire line, because we're not going to be doing C++, all right? Additionally, this top line here called include, this is basically your import statement for extra functionality. By default, you have no functionality. If you delete this line, you have zero functionality in your application, all right? To get pretty much any functionality you want, you're going to have to import stuff. So the Python library by default includes a good amount of stuff. In C, it includes way less. All right, to get anything basic like printing out to on the screen, you have to import it. You have to import it from scratch. Now we're going to be programming in C. So this default one that you got here, IOStream, all right, IOStream. What does IO stand for? You should know, all right? We've gone over it many times. Input, output. So input, this is in regards to anything that's doing input and output, specifically the terminal. So displaying stuff is an output. Taking data in is an input, all right? So this is specifically for C++ though. We're not doing C++, so you can go ahead and delete that. Instead, you guys are going to do the £, or hashtag, and then we're going to say define, all right? After that, to import stuff, we have to wrap it around. If it's a part of libraries we've imported, we have to wrap it around in these less than and greater than sign. That is the less than sign, right? Yes, less than and greater than sign. Inside of this, why are you not bringing up my... Did I type the... Hold on 1 second. Undo. Sorry, include, not define. All right. £, include, and then less than, and then we're going to do standard IO. There we go. Standard IO.h. All right. Standard IO.h. STD. All right. We're all going to get infected together. And then IO.h. This is the old C, just the original C IO library, input and output library. This is different than the C++ one. Like I said, we're doing C, not C++ right now. To print in C, we're going to type in print F. And then we're going to do a string here and say hello world. All right? And you get to be introduced into something more cancerous than Python. All right? This concept called semicolons. Go ahead and run your program right now. You're going to get an error. And it's going to say there were build errors. I'm not going to continue. And luckily, it's a little bit easier to find out errors and where they are and what they are when you're in IDE. An IDE is better than a text editor, right? So VS Code is a text editor. It's very, very basic, at least up front, and it's just meant for editing text. An IDE is an entire development environment for developers, which means it's going to have a lot of tools. So you're going to see here in this list down below, it's going to tell you there's an error, and if you double click on it, it's going to bring you as close as possible as it can to where that error is, and it's going to be pretty descriptive on what that error is. And I wish I could zoom in on this more, but you guys are kind of out of luck. So you can look at your screen for that. All right, it says we're missing a semicolon. At the end of almost every single line in your C code, there must be a semicolon. C is not a white space sensitive language like Python. What was white space sensitive? That means Python cares about your spacing, your tabs, your everything. That is not the case here in C. In C, spacing does not matter. You could have your whole program look just like this. All right? It looks crazy. I could even do this. It looks crazy, but if I run it, it's going to work. Maybe not with the include. Sorry, went a little too drastic there. There we go. It will work. All right, it will work. It's going to look god awful, but it will work. And we'll see hello world gets printed out. All right, hello world gets printed out. It does not care about spacing. It does not care about white space. How you tell a program in C that the line is over and you would like to move on is with semicolons. You must include semicolons at the end of almost every single line in your program. We'll tell you anytime there's curly braces are the only exceptions, except that even has an asterisk. I don't know if we're going to be getting that far though, but basically rule of thumb moving forward, if there are curly braces, you don't need semicolons at the end of the curly braces, all right? But for everything else, you need a semicolon at the end of the line, all right? You're going to run into this issue about 50,000 times, even though I just said it. Don't worry, it happens to everyone. So as we've just introduced, to print stuff in, in C, we use printf, all right? We use printf. Now, if you're on Mac OS, you might be getting a little bit weirder of an output. And I don't know how it's on Replit, but you may get the same weirder output. What do I mean by that? Well, if you're in VS Code, let's do another printf, all right? Let's copy this and paste it. So we should see hello world twice. And if you are following along on any of those other devices, do the same thing, all right? Do the same thing. Have printf hello world here twice. Make sure those semicolons are at the end. And then rerun it, all right? Rerun it. Why is it? Hello. Me on. I need to. There we go. Sometimes it acts weird if you don't close the previous program in your VS Code that was running, so you can click on X and then like try to rerun it again. You'll see here, the weird thing that's happening is that hello world is now printing out twice on the same line. But why? Why is this happening? This has never happened for us before. Every time we've done print before, it would be on a new line. Yes, that's a Python specific feature. By default, in a lot of programming languages, they will not print on a new line for you, right? They will not print on a new line for you. They will print on the same line. You have to add your own formatting. The F in printf means print with formatting. Printf. Print with formatting, right? F stands for formatting. You have to include your own formatting. So if we want a new line, we have to include the new line ourselves. All right, we have to do backslash and n. If we rerun this with backslash n in here, you'll see we get it on a new line now. And depending if you're on Mac OS, you might need to add another /n on this last print statement, because you'll get some debugging information included in your program or on your final line there, which is kind of annoying. All right. Now, to get around some of this annoyance, sometimes it's common to see people with a printf /n at the very end of their program, right? At the very end of their program, so they don't have to include that in whatever is currently their last print statement, right? And forgot my semicolon, so let's go and put that there. We're going to forget semicolons all day today, all right? All day today. Any questions right now before we move forward? So printf allows, go and put any questions that you have in, but printf formatting allows for a bunch of different formatting, all right? A bunch of different formatting techniques, and a lot of them are used in Python, and a lot of them are not used in Python. And we'll see that here moving forward, how we can see those, all right? We're gonna see them literally up next, because you have to use them. You have to use them, all right? Because we're at the level where data is data, and it's kind of ambiguous unless you tell things specifically what they are. Python kind of spoils you. JavaScript kind of spoils you. Most modern languages pretty much spoil you. They will have a logic behind the scenes that will kind of auto-detect and imply what type of data you're trying to utilize. Strings, integers, floating points, etc. The lower down you go, the more ambiguous everything is. This can be a power move or a massive technical difficulty. A lot of young devs who leave college that learn C and then go into C jobs will make some of the biggest and terriblest mistakes in the entire world that cause major companies to be exploited because you're at a very low level. Things are extra important when you develop here. This is not as forgiving as Python, and it can be extra worse when you mess things up for a multitude of reasons, right? It's easier to crash a computer at this level. It's easier to make oopsies and get things exploited at this level. All right, there's very little hand holding that goes on here. And the little bit of hand holding there's always, imagine your room is messy after being lived in for a while, and they tell you to clean it up and throw out all the old stuff in the trash. All right, normal person would do that, right? Well, in SeaWorld, you can't. They have to have backwards compatibility to a certain extent. So in essence, all of the dirty laundry from C, the exploitable items that have been with C since the beginning of its existence, is still in the language, and you can still use them. If you look up solutions, you will find exploitable solutions, all right, that you might copy and paste in your code. So the only way to know these is by looking around in C, messing with C, and being all enveloped into C. All right, we'll talk about a couple of them, but effectively, trash is never taken out. In C, it's always swept underneath the rug. All right, it's still there. It's still accessible. Anyone can use it, and they can get themselves in deep hot water. All right, let's see. See, no questions for now. Let's go over how to make a variable. All right, because this is gonna be a little bit fun for you guys. All right, so let's keep our hello worlds here because it's code that works, and we're gonna need some picker-uppers here. All right, because it's gonna be a little rough for some of you guys. In Python, when we want to make a variable, we say something like my cool var equals 4. Ooh, that was rough. As you can see, doesn't like it in C. Why? Because in Python, it does nice things like figure out what this variable is supposed to be. In C, they don't trust you. It's not they trust you. They don't read into you at all. You must be explicit. You must tell it exactly what you want to do. This is what makes C so efficient on many different languages, processing wise, but memory efficiency. You must tell it what type of variable this is supposed to be. This variable, we want it to be an integer. So if we want it to be an integer, we need to tell it we want it to be an integer. So at the beginning of the line, we have to say int space myCoolVar equals 4. This is us telling it specifically it's a integer. Now remember back to operating systems it's operating systems and networks and protocols, all right? Both of those modules. We talked about data. We talked about binary data. We talked about bits, bytes, nibbles, words, double words, quad words, and the sizes they take. The sizes that they take in memory depend on the operating system you are programming in. But you can also see how much they take up here. This also includes the upper and lower boundaries for your data. So your integer can have overflow events here in when you're programming in Python. I think it's 4 bytes by default. We'll figure out here soon for Windows, but we'll see. Additionally, if you want a value that is not signed, you have to specify you want an unsigned integer, all right? And you can do that with, by saying unsigned space int space my cool unsigned var equals 4 or 5. I guess it's gonna be 5 now. So now we've made 2 different variables here. One is called myCoolVar, which is going to be of type int, right? Of type int. So it's a integer value, which means it can only ever be a whole number. It can never ever exist as a string, ever. Unsigned integer over here will only be a whole number with a positive value. It will never, ever, ever be anything else. That doesn't mean you can assign it, or that doesn't mean you can't assign it something else. And I'll show you that here in a second. All right, let's print these out and see what they look like. All right, let's print these out and see what they look like. So can't find my print button. I've posted a SS in supporters chat. There's a big play button. All right, this is the talk we have to have now. All right, I got to do some strangling of you. All right, there is a big old play button. All right, hold on, let me pull it up over here. There's a big play button right here. You got to click on this. Also, this is going to error out because symmetry is the game here. Symmetry is the game here. If you ever start with a curly brace, you must end in a curly brace. You have 2 opening curly braces and only 1 closing curly brace. All right, there's an issue going on here. To solve this, delete that curly brace on 13 and pay attention to the symmetry of everything. It's very important. All right, it's very, very important. It's very easy to screw up the syntax here in C. So the curly braces here, before we move forward, this is a function. All right, we have a main function. All right, this is where main comes from in Python. In Python, main is an arbitrary term that is legacy from other languages. What other languages? From C, of course. It was written in C. Python was written in C. Main is required for C, right? For running a program, right? For running a program. Main is the default term that's agreed upon that will execute, right? Will execute. It is the function name that will auto execute. If you change this, your program will no longer work. If I change this to ASDF, you can have a function named ASDF, but now if I run this, you'll see our program will no longer work. It will no longer run. You must have a main function because that's where it knows when to begin its execution, all right? Again, we're in arbitrary land where things don't know anything. It's just data. It's things that it's in a very dark world. Think of outer space, and it's just kind of looking around trying to figure out what is what. Anything can be anything at any time. It's up to you to put order into this space, all right? So let's print out these variables real quick. We can use printf to print out these variables. Now you may try to say printf and then put your variable in here. Remember your semicolon on all of these lines. And you might try to run this. This will not work. This will run into errors. Because when you try to print data in lower level languages like C, it doesn't know what this data is. It knows you gave it data, but when it looks at that data, it sees that it's an integer, which it doesn't know how to deal with it. And if we hover over it, why aren't you... Oh, well, it would help if I spelt this correctly. If we hover over it, it's going to say that it wants this thing called a const char asterisk underscore format. All right, a lot of complicated words there. Effectively, what it's asking for and what that means is it's expecting a string. All right, we're not giving it a string. Right, we're not giving it a string. It does not know how to handle data that is not a string, period. And it will not attempt to mess with anything that is not what it likes. It's very, very picky at this level. It must be exactly what they asked for, or else it ain't going to work. It ain't going to ship, all right? If it doesn't fit, it doesn't ship, all right? So how do we tell it how to print this data? And how do we put it into a string? Great question, all right? What we do here is we make a string, all right? And inside here, we can do %i, right? %i. Why %i? % is a special character, all right? Special character in C. I means that the value that we have following up, this data right here, is supposed to be an integer. So if we run this, you'll see that it will print now. And it will print 4. It will print 4 right beside the hello world because remember, new lines don't happen on prints here. So let's go ahead and add a new line right here. So the formatting looks a little bit better. And let's go ahead and rerun this. You're going to see that we get our 4 now right here on this line, which is really, really nice. Again, we had to print out a string, and in this string, we must tell it that we want that the following value is going to be an integer, because by default, it doesn't know what data is what or what it's supposed to look like or anything, all right? It's just data. So we must imply order in this world. All right, we must imply order in this world. So the syntax is comma and then my cool var. Let's see here. What defines a high level and low level language? It depends on who you ask, in what context it is. The traditional definition is that low-level languages are going to be any type of assembly-like language. So x86, x64, ARM, those are going to be your low-level languages. And then every language beside that you think of as a normal programming language is a high-level programming language. In modern terms, when you're talking about modern programming languages like Python, C, Java, etc., they have their own hierarchy. And C would be a low-level language compared to Python, all right? So it just all depends. And other people will disagree, agree. I don't care about them. I don't care about their opinion. C is a low-level language in the modern world, all right? Let us move forward here. So how do we print out our unsigned value? All right. If I stands for E or integer, then you're right. Whoops. Why did it pull this up? You're right. U is going to stand for unsigned. All right. We don't need to do an I. We can just do a U. And if we run this, you're going to see that it's glitching out. So let me close that out and rerun it again. We're going to see we get 45 printed. 45. Why? Because remember, we need those new lines. So let's go and close this out. Let's go back here to this line right here. Let's put a new line here so they're not printed on the same line. And then let's rerun this. And there we go. Now we got a 4 and a 5 printing out. That's pretty cool. You're right. That is pretty cool. All right. That is pretty cool. But remember, all data is arbitrary at this level. You are saying what the data should be at every step in the process. Literally everywhere you dictate what shall things be. All right? You might look at this in the real world and say this is a pen. In programming world, you can call this a pen. You can also say this is a dinosaur. And guess what? You're right. This is now a damn dinosaur. All right? It can be whatever you want it to be. It will conform to your will. You have absolute God tier everything. All right? You like anarchy, you want control, you program. This is absolute control. You can will things in existence in any shape you want it. And if you feel like calling this shape something different the next day, you can call it something different. All right? We're going to see that here in action. We don't have to command S to save. So you can do Control S to save. Also, the IDEs are very nice tools. So when you click the play button here, it will auto save for you, or it should auto save for you. All right, before it runs. So that's what you might be experiencing. It's always best to Control S though and save. So unsigned integers are not supposed to have negative values, right? You're right. They're not. Guess what? I'm going to make this a -5. because I live on the edge. But also, I know that I am a god, and I can say anything I want in programming world. Alright, so I say this will be -5. When we run this, you'll see it works just fine. Except for our data here. It will be a very, very, very high number. Why is it a very high number? Well, because you are a god, but you didn't change all the rules in this mortal world. Alright, you only did one thing with your godlike powers. You set this data here to -5. Remember, all data is just data. What does it look like at the file disk level in memory? All right, it's ones and zeros. A 1 and a 0 can be anything. All right, it can be string, image, audio, but it's ones and zeros, and it's up to you to interpret that data into something legible. Here, we are saying that this data is going to be stored in memory as an unsigned integer. All right? In memory, it will be stored, the layout of it will be stored as a unsigned integer. What does that mean? Well, remember when we talked about unsigned integers and signed integers and we did the binary math for them? Yeah, it's all coming back because it was all important. So I hope you didn't forget that stuff because it will be on the test. All right. When we go back to that stuff, you'll remember that things are grouped together in nibbles. So if we have 1 byte of data, it's going to look like this. An unsigned integer will count and fill up all of this data just fine. This whole byte of info. A signed integer will reserve the most significant bit for the sign, whether things are negative or positive. This is used for the data. That's right. So when you say unsigned integer or integer here, all you're doing is you're telling the computer how it should format this data that we're putting inside of it, right? This data, these values we're putting inside of this. The format is still interpreted the same. But remember, it's only formatted there as a formatting. It still doesn't know what anything means. You still have to give it more meaning. What do I mean by that? Well, in this printf here, we said unsigned integer. It's going to print this as a unsigned integer. Keyword there. It's going to print it as an unsigned integer. We have to tell printf how to print this because printf literally doesn't understand what this is besides ones and zeros. Which means if we want, we could say integer here, an I, and rerun this, and you'll see now our unsigned integer is printing out as a -5. Because data, again, is just data. It's binary. It's 1 and zeros. It can be interpreted in any single way you want it to be. All right? Need you to understand that concept. It can be done and interpreted in any way you want it to be. You saw this, and one day it was a pen. It was an unsigned integer. Cool. It was. Next day, you're saying in God tier mode that you are in right now, this is a damn dinosaur. Congratulations. Your will is my command. This is now known as a dinosaur. And as you can see here in printf, it is now known as a dinosaur or a signed integer. A signed integer. Even though it was not initially called that, it is now being interpreted as that because you told it to do that. All right? Because at the end of the day, it's, again, repeating myself a lot here because I'm trying to make sure you understand this concept. Data is just binary, generic ones and zeros that have absolutely no meaning at all. Its existence is meaningless. You give it meaning. All right? You give it meaning. All right. Any questions so far? All right, we're going to show 1 or 2 more things here, and then we're going to go on break. For a float value, you must say float. So we'll say float, and then we'll say my cool float, and then we'll have it equal to, I don't know, 1, right? Doesn't matter. It could be any value. You could say 1 point this. It doesn't matter. It will be stored in float format. Next, we have these concepts of doubles, which will be double the size of my cool float, right? It will be double the size of a float value. So if you need super precise, I'm going to put decimal places here so you guys don't get confused. If you need super precise data, you're going to want to use doubles for your decimal place logic, not floats. Floats are not that precise, all right? They're precise enough for a lot of things, but not for everything, all right? Next, we're going to do char. We don't have strings in C. There is no concept of strings. There is no variable type called strings. Strings do not exist. Strings, literally, the word string means to string characters together. In the beginning, there was just chars, just characters. So we can say my cool char equals, and it takes one single character, right? One single character. Why do you not like this? Hold on. There we go. We gotta do single quotes, all right? Doesn't like the double quotes. Do single quotes. There is no concept of strings at all in C. Does not exist at all, period, all right? You have to hack together a string, right? Because a string is a string of characters. Those are the keywords there. A string of chars, a string of characters. It's literally called that for a reason, because you had to do that in the good old days. It's a legacy term. But earlier you said the code wasn't running because they specified int because, yes, I did. You'll see. All right, I'll stitch it all together. Don't worry. I'll stitch it all together for you. Don't worry, Cole. I got you. Just know there is no string variable type. Do not go in here and try to make string. I think, okay, because I know I'm pretty sure there's one in C++, but in base C, there is no string. All right, doesn't exist. All right, so we've covered some data types. I think we're missing one more, bool, right? Bool is for booleans, so my cool bool, and that can be a true. It's all lowercase, true or a false, all right? True or false. And I think that's pretty much it, besides getting into structs in pointers. So this is pretty much all the variables you have. This is pretty much it. After the break, we're going to talk about arrays. But here, before we go on break, let's go ahead and print out the rest of these. So let's do printf, and we're going to need new lines on each one of these lines. And we're going to do % f/n. Will that one work? My cool float. One second, let me run this. Whoops, forgot the semicolon here. Yes, F is for formatting. This one, I think we can do D. No, we can't do D. Oh God, I always forget this one. One second here. Let me pull up my reference guide. You bastard. It was F. Why are you erring on me? Truncation from double to float. Oh, whoops, I changed. These are named incorrectly. My cool double. And we're getting 1. Perfect. Let me do like 1 right here. All right, copy and paste, and then this one, my cool double, and copy and paste, and this is gonna be an S. That should work, right? We're about to figure it out. And then Boolean. Oh, what was Boolean? I'm gonna guess a B. We'll see. All right, that looks about right. The Boolean though didn't really, I guess the char didn't really print out too. Is it a C? Print char. Yes, it is. I should have known. And then this one is gonna be a Boolean. Yeah, I didn't think it would. You can do, yeah, an integer. All right, perfect. That will work. That will do. That will do. All right, so you guys can go and copy what I got here. So let me pull up the chat. So I, integer, U, unsigned int, F for floating. You're gonna need to, I don't think you need the leading 0. Let me run this again. Yeah, you can remove the leading 0. Basically, this is the format of how you want your float value to print out. This is %(1)f. This means that you want the decimal place to have precision of 1. All right, precision of 1. That's how many decimal places are printed after the 0. If I change this to a .2 on my double here, you'll see now when I rerun this that the double will have 2 precision points, or points of precision after that are printed out. All right, and you can keep increasing this all you want. All right, and then I don't think, yeah, okay, it can. So if you just do %f, that will print out a generic amount of decimal points for your floating point variable. So that can work. C is for printing a char, and Booleans don't print out anything, because remember, Booleans are just going to be arbitrary data. It's not going to add like a true and a false for the printout. So instead you can print a Boolean as an integer, right? So that's why we have I right here. You could have U. They should both work exactly the same. All right, I and U should work exactly the same. Why? Because again, data is just data. If I have a byte of data and I tell you there's 00000 and then 1 right here, this could be a 1 integer value. It could be a 1 unsigned integer value. It could be a 1 for the corresponding character value, which is, I don't remember, it's one of the special characters that doesn't display anything. Or it could be a Boolean value, which could be of true or false, right? Of true or false. It's just data, and it's up to you on how you want to interpret it, all right? Same thing here for when we're printing it out. It's totally up to us on how we want to print it out in the format, all right? So hopefully you guys all got this, all right? Hopefully you guys all got this. We're gonna go on break for a couple of minutes here, 3 to 5 minutes. And when we come back, we're going to talk about arrays, all right? Arrays. And these are actual arrays, all right? In Python, it's a little weird because they call them lists. There's a reason why they call them lists compared to arrays, but they work just like arrays and lists work pretty much exactly the same, all right? And you'll kind of understand the confusion. And a lot of people will just call them arrays because, again, array is a term from these other languages. All right, so I will be back in 3 to 5 minutes. All right, if you have any questions, put them in the chat, ask away, and I'll answer them when we get back. Alrighty. We are back at the grind. So if anyone's new joining in and watching, this is not the time to join in. We're going to be moving very, very fast. We're going to refer to concepts we've already covered in previous weeks. All right. And we are not going to stop and recap a bunch of stuff all over again. All right. We're going to assume some things, and we're going to maybe lightly retouch on other things like we did for the binary layouts. All right. But we are full force ahead. All right. Full force ahead. Before moving on any further, though, just in case you were confused on where you're at, welcome to Rootkit. All right, we're a nonprofit here in the US of A who certifies individuals in the comp sci field. All right, our comp sci cert is the best comp sci cert, period. All right, it just is. All right, straight up. And now I forgot what I was saying. Oh yeah, don't go to college. Don't go to any other boot camp. There's no reason. We're doing this right now. You're watching. You made it here. All right, just get our cert. All right, just get our cert, and we'll get you a job. All right. I didn't even have the cert. All right, till I helped stood this up, and I was able to get jobs. All right, and look, now we got a cert. We've paid the path. We've done the hard labor. We've already done the non-cert way, making it through XYZ. Oh, how fun. All this pain and people doubting you, XYZ. You don't need to go through that anymore. You get the cert, you get a job. It's just that easy. All right. Now, on top of that, we have our blog. On top of all this free info we're giving you, we have our week 9 giveaway going on right now. You could enter this, all right? And you could win yourself some merch, all right? We just pulled week 8's winner, and now we got week 9, the mystery item. I don't even know. We're going to figure it out together this weekend because we're going to pull a random number, and it will correspond with one of the merch items. If you like what we're doing and you want to help support us, because making content for free and running a nonprofit ethically, we could run it more like Harvard, where we have a nice little bank account of $50 billion and invest in funds and real estate and not into people and education. Or we could run it ethically and where we spend every money and barely make ends meet. All right. Some people would call that stupid, but we're here. We're doing what we can. If you want to help support us, you can go ahead and go to the link in the description or in the bio of the Twitch somewhere. All right. And you can donate. All donations are being matched 1-for-1 for the first 10,000 donations. Those roll in at the end of the month. And depending on how much you donate, you can unlock rewards like our stickers, our Epic Collab t-shirt, and this epic sweater I got on right here. And it has Rootkit on the back. It says 100 Days Rootkit right here with the little mascot. And we have pillars along the way, like streaming for 24 hours straight, shaving my head here live on stream, and choppy of the beard, but no one wants to see that, so we're not gonna get there. All right, that's our goal, is not to meet that goal. All right, so if we don't meet it, we're winning. Why did this change back? There we go, much better. Let us continue on. I think I've hammered on the point that data is data. It's arbitrary. It's just ones and zeros, and you can interpret it however you want. All right? Remember this. It's very important moving forward. All right? Especially when we get to pointers. It's very important you understand that concept. All right? Because every language you're going to program in, JavaScript, if you want to be a web dev, Python, if you want to be a general dev, all right? They use all of this under the hood. It's doing all of it. Whether you see it or not, whether it was written in C or not under the hood, every language is doing this in some type of capacity. You need to understand that this is a universal theme, a universal concept, all right? This is in every language. Yes, Kamal, you did win the last one. So I need to, you got all of the stickers. All right, so I need to collect your address. You never added me back on Discord. I didn't email you because I knew I could just add you on Discord. All right, so let us move forward here. Now, I said there's no concepts of strings in C. Now, that's not wrong. But it's not 100% true either, all right? As Kamal tried to egg me on. No hoodie, hey, it's RNG, all right? All I gotta say is you were very unlucky because when I re-rolled after the stream, I said on stream that both Jamie and Evox can't do the competitions anymore because they're literally winning. Both of them have won 3 times, all right? Their RNG is insane. Literally, when Jamie said, re-roll the prize, I re-rolled it. Guess who I pulled? That's right, your boy Evox. Is he in here right now? Yeah. Absolutely ridiculous. So I had to re-roll again, and then you were chosen, all right? I don't know, man. Just unlucky. Hey, just enter into... We got plenty of more weeks, all right? Just keep entering in. we'll definitely land on another sweater. So don't you worry. All right. So let us trek on forward here. There is no concept of string. There is no variable type called a string, right? String is a concept that is made up after the fact because you can do things like make arrays, all right? What is an array? Great question. It's just like a list, all right? We use the brackets, all right? So below this, I guess moving forward real quick, comments. You've already seen it. This is not the pound sign for comments. You use double slash, right? So in here, we can do double slash and say, this is my comment, all right? Put lots of comments, all right? So as you've seen so far, variables pretty much the same as they are in Python. You already knew this stuff, all right? Maybe it's a little bit annoying for remembering the types of what variable each is, but you already knew this. This is a new concept. As you can see, the syntax is slightly different. Comments. There are comments in Python. You know about comments. You know how to do comments. There's just a slightly different syntax. All right. Print statements. They're the same in Python, except they're just called print. There's a slightly different syntax here, but they work the same way. All right. Like I said, you learn one language, you learn them all. You just need to learn the slightly different syntax. All right. So we're learning the slightly different syntax right now. That's why we're going at quite a fast pace right now. So next, we're going to show off lists. You can have, arrays. I can't say list anymore because these are not going to be lists. These are going to be all arrays. All right. Arrays, very easy to make. All right. If you want an array, you can say int. You can make an array for anything. For anything, it can be made into an array. So we'll do int my cool int array. All right. And hopefully this is the format for it. 1, 2, 3. Maybe this is just for strings. Oops. Oh, this is supposed to be. All right, what is it not like? Expected, blah, blah, blah. Okay, maybe it's. 1 second, let me check my notes here. I'm like one little thing off. I can feel it. It's making me angry. Why you gotta do this to me? Everything's a pointer. Where's my array example? All right, C array. Thank you, W3 Schools. Oh, that's what it meant. Okay, so you don't use. I can get rid of this. Don't use brackets right here. You use curly braces. I knew I was one little thing off. All right, you use curly braces right here. As I said, syntax for everything is different. So Google, 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 Google. All right. It's going to be different in Python compared to Java, compared to C, compared to everything else. All right. They're using curly braces. So this is how you make an array. All right. This is just like how you've seen in Python. All right. You make a list of comma separated items, and that will be your array. Here, the syntax is slightly different. To make it an array, you need to put brackets right here. By putting brackets right here with no number inside of it, it means your array can basically be any type of length. But you can decide what length that array is going to be based off the data right here that we're going to stuff inside of it. All right. So it can see that there's 3 items here. So when the compiler looks at this, it will see there's 3 numbers here, and it will know this is going to be an array of length 3. And it will do that auto-magically for you. If you don't know what the length of your array is, you can't say this. As you can see, it's getting mad. You must put in the size of your array. Unlike Python lists, where you can just add, delete, remove, whatever you want to do. In C, your default arrays are unchangeable in size, which means if you say your array is going to be of size 5, it is of size 5. It will always be of size 5, whether you use everything or not. It cannot be changed. It will always be of size 5. It cannot be reduced. It will always be of size 5. It is size of 5. You must know the sizes of everything in C when you compile your program. There is no potential arbitrariness to your statically defined variables. What does statically defined mean? It means you've hard-coded them, right? We've hard-coded them. When you hard-code your values like this, they will go somewhere specific in your RAM. They're going to be going to the stack, all right? They're going in your RAM. Remember the RAM layout? That is on the test, all right? That is on the test. Everything that's statically defined like this will show up in your stack. And your stack must know the size of these things, period. It does not dynamically grow in size. It must know the size of these things beforehand, all right? So these are called arrays also, which is supposed to be different than lists because, again, you can only not have a number here if you're using curly brackets and you're specifying what items are in here. So this would be an exception where you still need a semicolon after a curly brace. All right. This is called an array, and it's slightly different than what they call it a list in Python because a list can hold any type of value. Arrays can only hold one type of value. If you say this is going to be an integer array, all right, it's going to be for integers and integers only. You can't have different types of data in it. Now, of course, data is data, so you can stuff any type of data you want in it, but it will only be interpreted as an integer, all right? It will only be interpreted as an integer, so be aware of that, all right? Pretty much all your variables here will have one singular data type about it. There's not really any type of flexibility in regards to changing your variable types like you have in Python, where you can have it as a string one moment, you can make it into an integer, and then make it into a floating point, etc., etc. There's not really any major concept of that here. When it is decided to be something, it is that thing, right? There is casting here, though. There is casting here, and we'll kind of show that in a bit. So just like in Python, you can make something into something else forcibly. You can do the same thing here. If I want to make an unsigned int array, it's easiest just to copy and paste code. The only thing that makes an array is adding these curly braces here and then saying, whoops, and then saying 1, 2, 3. This is the same for floats, doubles, and bools. There's nothing different in the format at all. They're the exact same. So we're going to not type out those examples because it's exactly the same. All right. I guess I'll make this one. I'll just show that you can say like 3. There we go. What we will show off is strings. Again, there is no concept of strings here. It's an array of characters. It's a string of characters that are in an array. So if you want to have a string, you will say char because they are just characters. And you will say my cool string. And you're going to say equals. And remember, we need those, what do you call it? Brackets. And then here we'll say hello. I have a string. All right, remember those semicolons. Also, these need new names. This is array, my unsigned var array, so we don't run into any errors. All right. Why won't it print my cool array? Great question. Because you can't. All right. It's not as simple as that here in C, all right? Because it doesn't know what an array is. It knows what the individual items in an array are, and you can print those out, but you can't really print the array, all right? Well, you kind of, this is where it starts getting into more pointer-ish territory. We'll see here in a second. But before we move forward, let's just run this as it is. We're not printing these out right now, so we won't see these print out, but we want to see if there's any issues. All right, so if we run this, you're going to see everything runs just fine, so we don't have any issues. So let's see our string now printed out. If we do a print f, we can do %s. %s is for your string. Where is my percent sign? There we go. %s is for a string of characters. So if we say %s space my cool string, and then semicolon. I can't remember if this will work or not, but let's go and run this. Oh, it does. Perfect. All right. So we see, hello, I have a string. So now it is working. %s is a very special term that will handle an array of characters. All right. So again, no strings. There's just an array of characters. You'll also see that there's potentially some weirdness going on. All right, some weirdness going on here. What do I mean by that? Well, let's figure out how to print data sizes. All right, data sizes. And my notes are failing me right now, so we're just going to go ahead and Google this. So if we go over to Google, we can say C get data size. Size of, that's what it was. All right, so there's a special function in C called size of. All right, size of, which will tell you the size of your variable in bytes. Remember, it's going to be in bytes. All right, and we can print that out onto the screen and see it. All right, so let's, here at the end, let's see the size of our string. Printf %. I think this one's going to be a ZU. YZU. I'll get to that in a second. Size of, and then my cool string. All right. So let's go ahead and run this. And I forgot the semicolon, of course. So let's go ahead and rerun this. And now you'll see here, I want the formatting to be nicer. So let me put a /n right here and click on play. And now you'll see that we get 25 printed out is the size of our string. 25 is the size of our string, all right? Now, this is pretty cool. What is this ZU? ZU is what you use for an unsigned long variable. So an unsigned long is going to be a very, very long unsigned variable type. It's going to be pretty much the largest size you can get out of the bat in C. All right. Why is it unsigned long for size of? Great question. Because size of doesn't know what you're trying to get the size of. It may be very, 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 very large. So it's going to output the largest possible data format it can, so it can handle potentially any use case you throw at it. All right. So if we want to see how large an unsigned unsigned long is, we can say size of unsigned long, and this will tell us how long a unsigned long is in C. Oh my God, not Python. And if we see here, I gotta rerun it because it's glitching out. It's going to be 8 in size, and these are all clumped together because we're missing our /n's. So let me put /n right here and rerun this. There we go. We can say it's going to be 8 bytes in size. That is a very, very, very large variable. What is a long, you might ask? a long is a integer that is extra long in length. A long is even longer than a normal long. All right. And then unsigned means it will not handle signed values. All right. It will not signed values. This language scares me. Lol. Yeah. Sorry. I guess I forgot to cover longs. So I don't think you can have long by itself. You have to, yeah, you can't have long by itself. So long by itself will be an integer value. You can also just say int long. All right. Long means it's going to be twice the size of an integer value. And if you don't know, if you forget that, you can always measure it. That was supposed to be a tape measure sound. Let's say my long. All right. And if we measure both of these, so we're going to measure my long, and let's go and copy pasta. We need a /n right here, and say my cool var. So the bottom one is going to be our integer, and the top one's going to be our long. All right. And you can see they're both the same size in window by default. So not the best example right here. So long will be double that size. All right. So an integer in Windows, okay, if you're on Mac OS, you may see different results. Or if you're on Linux, you may see different results. If you're on Replit, you may see different results. Because this will vary based off the operating system you're on. Because each operating system handles this differently because, again, it's arbitrary. So longs and ints in Windows are going to be the exact same length. They're going to be 4 bytes in size. So if we change this instead to a long, that's when it will enter our 8 bits in size. All right, 8 bits in size. Why would anyone ever choose to code in this language over Python? Because it is literally the absolute most God mode you can have while being fast, or relatively fast. Because think of it. C came out in what, the late 60s, early 70s? When did C come out? So it first appeared in 1972. Pretty sure it was in development in the late 60s. Before that, so it's the successor to the language B. So C was made after the language B. I don't think it was made by the same creator. I think they were just following the naming scheme. It was made at Bell Labs. I guess it was made between 72 and 73. Okay, so I'm wrong on that one. And think of it. At this time, it was pretty common to program in assembly. All right. I don't know if you've seen assembly. I'm pretty sure I've showed you guys assembly before. Hello world in assembly. Welcome to assembly. All right. This is what your option was. This or this new cool language called C. Now there were competitors to C, but C was the best and the nicest one for the formatting. It had lots of power, but additionally it was made by Bell Labs, which was absolutely massive company back in the day. You can think of it more like your HP equivalent. Yes, it came out a very long time ago. Yes, it's still relevant today because it's that great, right? It's that great. Now they got more competitors around. There are competitors. There's always been competitors to C, like Fortran and Pascal. Pascal was, am I confusing that one? Pascal language. Yes, Pascal was the main competitor. And Pascal, I believe, was, yeah, it was kind of like Python, and it was white space sensitive. All right. But these weren't as versatile as what C was kind of trying to introduce. That's C++. And a lot of programs are written in these still to this day and still maintained in these old languages, all right? Because they are just that fantastic and that great at what they do. And you got to think of yourself in the time set, all right, or in the time zone. You have assembly, which is this, all right? Absolutely cancer. This is literally what you see. All of your favorite Nintendo games, if you're old enough to play the old classics, they were written like this. Pong, Tetris, name it, old classic game. They were written in this. This or this. It's not really, it's very obvious, all right? Now, C was kind of controversial because earlier on, the compiler sucked ass. So basically, when you write C, it will turn it, it's a couple step process. C will turn it into assembly, all right, by the assembler first, all right? And then it will be compiled from assembly into binary, right? Hopefully I'm not messing up those terms right now. So then it will be actual machine code, right? So it's a multi-step process. This is why it's called a high-level language, at least legacy-wise, because it was built kind of like Python. Python is written in C. C is written in assembly. So you can kind of see the concept there. At the time, it was kind of looked the same way as Python. But guess what? Python runs the world now. So same thing like C. C ended up running the world. So even though you do take performance hits, it's worth it. Because look, in C, you can be God, and depending on what religion, or if you are even religious, God created the world in, I don't know, a week if you're a Christian, all right? That's what you can do in C. If you're in Python, you can do it in an hour, all right? So it's up to you. Now, you can make it in a week, and it will be God tier in performance, in quality, in XYZ. But, you know, you can also make it an hour and then spend the rest of that time adding new features. Yeah, it might be a little slower, but guess what? It's going to do everything and more. All right? That's why Python runs most of modern tools. All right? Because the trade-off is worth it in most cases. All right? In most cases. If speed is important, you can't use Python. You just can't. It's so slow, right, compared to everything else. Okay, so yes, so far the most annoying thing is going to be the semicolons. Next up, for our print statements, remembering what character to use after the percent sign. Yes, it's a little annoying, all right? Luckily, most of it is intelligently labeled, but, you know, we move on. Remember, though, the other annoying thing is everything is arbitrary. So with C, you have more control over your coding. With C, you have absolute God tier control over everything, all the way down to its binary, like, lowest level. You can write assembly in C, all right? But with great power comes great responsibility. It's way easier to fuck up. It's way easier to ruin everything. It's way easier to crash your computer. It's way easier to make exploitable code. This is the code that when it gets exploited, usually it's not a good day, all right? It's also way slower to do anything. Way slower to do anything compared to Python development-wise. But when you do it finally, it will be way faster. All right? Python is kind of like training wheels. You can think of it like that, but it's not. Python's the real deal. Most of the world runs on Python. All right? Most of the world runs on JavaScript also. Those are like the two biggest languages for a reason. Not because they're training wheels, but because you don't need to deal with the cancer that comes with lower level languages. There are different tool sets for different reasons. You don't make a game in Python, all right? You don't make a full 3D game in JavaScript, all right? Those are shit tier languages for doing it because they're so slow. You use something more powerful, a compiled language like C# or C++, or don't use Java. Yeah, Python's cool and all. Don't use Java. All right? Do not use Java. It's slow. All right? It's not meant for game development. Minecraft is a great example of why it's so slow and why it's not good for game development and why Java sucks and you should not develop in it. All right, the age of Java is gone. All right, it's gone. It's over. It's been replaced. All right. Kind of like Android. Android users have more control. Yes, you can think of it like that. For Android phones versus iPhones, yes, you can think of it like that. But guess what? iPhones, you get a much better experience. Everyone loves it. Everyone's happy. It's pleasant. It's great. It just works. All right? That's the same with Python. With Android, it's pretty cancerous. All right? If you develop for Android, it can get very cancerous really quick, especially when you have to deal with the thousands of different phones with different screen sizes. It's just literally just put a bullet in my head. It's that bad. All right? It really is that bad. All right? That's kind of the equivalent here. But we're going to move forward for right now. You can mess with arrays the same way. So if I want to get one single value out of my array right here, I can do it the same way I do it in Python. All right? So we can do printf. And remember, we need our new line right here because I don't want them to be printing in the same space. We can say printf. Our array right here is going to be an unsigned integer. And I'm going to print one of these values out. So since I want to print one of the values out, I can do %s. Where's my percent? Not %s, sorry. %u, because we're going to be printing an unsigned integer value out. And now I can say my cool unsigned array, and I want to get maybe the first value. Remember, everything starts counting at 0. All right, so if I rerun this, I should see a 1 printed out. So if I run this, there were errors. I forgot the semicolon. Let's rerun this again. And we're going to see we get a 1 printed out. If we rerun this again with a 2 here, you're going to see we get a 3 printed out. So this is how you can print items in your array, right? You can print items in your array. So that's very convenient, very, very nice. All right. So we've gone over pretty much all the variable types that are important right now. You've learned that they all can be made into an array. You can specify the size of the array, or you don't have to specify the size of the array. If you don't specify the size of the array, you must define the entire array immediately. All right. For strings, to make strings, they are characters. It's a string of characters, which means they are going to be an array of characters. And you must, if you're not going to define how long that array is, you must say what the entire string will be right here, right now. All right. Additionally, I wanted to go over when we run this, you're going to see that our string is of size 25. Every character is 1 byte in size. A character is 1 byte in size. This string is 25 bytes in size. Now you're going to notice something's a little weird here. Specifically, if we make this a little simpler and we say 1, 2, 3, 4. All right, we have 4 items here, and technically the /n is going to be our 5th character. All right, these are 5 characters right here. If we rerun this, and I think it's going to glitch because I didn't close the other one, you're going to see that a 6 is printed out. Why is a 6 printed out? That doesn't make any sense. We have 1, 2, 3, 4, 5 characters here. I know there's 2 here. That's not really a thing. If you're going to make me do this, all right, look at what you're doing. You made me do this, all right? 1, 2, 3, 4. All right, so there's only 4 characters in here now. So if we rerun this and we look, it's going to say 5 right here. Why does it say 5 right here? There's only 4 characters in this string. Great question. How does the computer know when to stop printing? Great question. You might think it's very obvious. It's not, because data is just data. No one really knows how long an array is unless you tell it how long your array is. All right? it's it's very arbitrary. All right, it's very arbitrary. So to get around this issue, there's a special character called a null value. A null value. All right, if you look at the ASCII table, you'll see the first item there, 0, is going to be the null character. Right? The null character. This means that you're going to stop printing. Right? You're going to stop printing out. You can put your own null characters in here. So I'm going to put one in between 1 and 2 and 3 and 4. I believe this will also work in Python. All right, pretty much everything I'm showing you here with string formatting will pretty much work in Python pretty much the same way. So if we do a slash and a 0, is it /0? Yeah, I'm pretty sure it's /0. Well, I'm going to do a space right here because it's doing some weird formatting. This will introduce a null value. If we rerun here, you're going to see only 12 prints out, not the entire string. All right, not the entire string. Why is that? Because like I said, by default, not by default, printf will literally keep printing your string until it hits the null pointer, right? Till it hits the null pointer. It will not go any further than that because it will assume that's the end of the string. All right, so that is why you'll always have one extra byte of information on your strings, because there's going to be a null value. This is the same for every language. So if you're in Python, it's invisible. It's there. It's working the exact same way. All right, you just don't notice it, but it is there. This is the fine-grained control you have here at C. You can see it, you can mess with it, you can remove it completely if you want to. You don't need to have that there. If we say that we only want our list to be of size 4, we can do that and we can make a string of size 4. It's going to be very, very mad at us right here. I don't even think they'll let you run it because this is a potential issue, but you can do that. All right. A way we can get around it is we can give it 3 here, and then right below we can say my cool string. Gosh darn it. My cool string, and then value number 3, which is the 4th one, is going to be equal to this. Please let me change it. It doesn't like the double quotes. There we go. Now we've changed it. All right, now we've changed it. We've removed that null pointer that was there. Sorry, that was 1, 2, 3. Yeah, the 4th value. The 4th value is going to be the null pointer. We've removed it. So now if we rerun this, and it didn't like that, let me rerun this again. Now we've reran this, you can see there's a little bit of an issue going on. Congratulations, you've now introduced an exploit to your program. All right, this is the potential workings of a a stack overflow attack. All right, this is arbitrary code execution. All right, this is all the fancy things, the nightmares that everyone hates, and this is how easy it is to do it in C. All right, by a simple mess up like that. All right, because what's happening here is the null value isn't there, so it doesn't stop printing there. It keeps going on past that point and printing more data it finds in memory afterwards. So for example, where's my paint? I tell you that this is my whole string, but I'm missing a null pointer. Your data is in RAM right next to a bunch of extra data. This is more of your program. All right, more of your hello world program we have here running. It's all compressed right next to each other. All right. When you don't tell it to stop, it's not going to stop. You have God mode control. If you don't be specific, it will do exactly what you say it to do. even if it's arbitrary, which means it will just read things that it's not supposed to read. It will print them out. And if what it's printing out is bad, malicious code, congratulations, you've been pwned. All right? This is why it's important to sanitize your input. All right? Sanitize your input. Sanitize your input. Because if I'm a malicious user, I will give you input, and then I will give you more malicious input that will destroy everything, that will make it so arbitrary code runs. Just because Python seems like it's safer doesn't mean it's safer. It was written on C. It can be exploited with a lot of the same techniques C and C++ can be exploited with, because it is C and C++ at its core. All right? Yes, Minecraft was written in Java, and Microsoft, when they bought Mojang, said this is god awful, you boomers and your stupid Java. So that is why it's now there's two versions of Python. One is the classic one written in Java, and the new one, which I believe was written in, I want to say it was written in C++, but it would be kind of a sin if they didn't write it in C#, to be honest. New Minecraft language. Programming language. Not the Java one. I don't remember. We're not going to look at it. You can, is it now C++? Yeah. Okay. The Bedrock edition, which is the new one, was written in C++. All right. That's the one that has, so NVIDIA did the whole ray tracing in Minecraft stunt a couple years ago. Yeah, it only works in Bedrock edition for a reason, because Java is god awful for games. All right. It's so slow. You can't do ray tracing in it. So only the Bedrock edition, which is in C++, can use ray tracing. Guess what? Is also in C++. All of NVIDIA's drivers for their GPUs. So it's a very easy marriage. All right. They're using this. What I'm showing you guys right now, this is what they're using to program their drivers. So if you want to work at NVIDIA, you need to know C/C++. All right. Why you will usually see C/C++, and that's the lingo people will use. It's because C and /C++, they're intermingled. You know, it's like version 1 and version 2, except you can use both of them at the same time. They are case sensitive, just like Python, right? The variables, yes. Now I'm using camel case right now, and you can use camel case in C just fine. All right. It's more proper to use snake case in C. That's the typical naming convention you'll see in C, but it's totally up to you. Again, what a snake case, everything is lowercase with underscores in between. All right, with underscores in between. That is what you'll more typically see in C development. All right. Why? Because it was brought over as a concept from assembly. Right? Because in assembly, you will usually have underscored labeled variables. And so that was brought over, and that was the naming convention used, but you can use any naming convention. All right. Before we finish up today, let me make sure. We talked about strings. We talked about don't remove the null byte at the end of it. Make sure you have a null byte at the end of it. Also, variables can't just be conjured out of nowhere. All right. So if I wanted to say later on right here that I want x to be equal to 1 plus 2, all right, you can't just conjure up variables anywhere. You must define them. You must define them. Now, it may be kind of cancerous for you to be defining these things everywhere and having these definitions scatter all through your program. You may not know which ones you've used already, which ones are available, etc., etc. You can predefine stuff in C, which I really appreciate. All right, which I really appreciate. And it's kind of cancer that you can't really do that in Python. Well, you can. It's kind of a hacky way, but you can predefine variables in C. What does that mean? Great question. We can take all of the variables that we want to utilize, and we can put them at the beginning, which usually is the predefining part. All right, we're going to put them all at the beginning, all the ones we've ever made. This is not required. This is just something you can do. And we're going to remove the assignment part from all of them. Semicolon. Well, let me just not do the semicolon. All right, now I got to re-add my semicolons everywhere. There we go. Remember, arrays that are not defined for their length must be immediately assigned the values that will go inside of them. Since we're not immediately assigning the values that go inside this one, we can't predefine this. So we will remove this. Everything else here we can predefine. Basically, we're saying that we want these variables with these names and this type of data inside of them. We don't know yet when we're going to use them or if we're going to use them, but most likely we are going to use them eventually. And these are what they are going to be. So now that we've predefined them, we can easily refer and see what has been used or taken here at the beginning. And later on in our program, we don't have to then state what their variable type is. So we can remove all this extra junk. And this can be a little, what do you call it? A little less, or I don't think this is gonna work now. This can be a little, I'm gonna uncomment this because your arrays are gonna break a little bit. Excuse me. So just comment out your arrays for now, because they're not going to like this all that much because you can't really do that. We'll get into that tomorrow, but this is a way you can make things a little nicer. You predefine everything up here, and so when you refer to them later on, you don't need to type out all that craziness. All right, you don't need to type out all that craziness, which is really, really nice. Okay, before we end, what else? We talked about predefining. We talked about our variables. Variables must, before their name, you must say what type of data they're going to hold. This is going to dictate the format the data is laid out in inside of the variable and how much data in memory it will take up. If you want to see how much data in memory it is physically taking up on your physical RAM, you can use size of to get the size of that variable in bytes. We talked about how to print things and how data is arbitrary and the computer has no clue about that data, only that it exists, and it doesn't know how you want to format it. So you must specify in your print how to format it. We talked about all the different percent cases you can utilize for formatting. All right. Semicolons, make sure they're there. Arrays work pretty much the same way as they do in Python. You just put in the type of data you want to get out of them. There is no slicing here. So like how you could do like 1:5 in Python. Yes, that doesn't exist here. All right. So no doing that here. And I think this is going to be about it for tomorrow or for today. So if you have any last minute questions, go ahead and ask them before I think I like snakes now. Go ahead and ask any questions. That's the recap for tomorrow. So, okay. So for your guys' assignment today, I want you to mess around. All right. I want you to make some variables, print some variables out. Additionally, your stretch goal is do some math. All the things I showed you math-wise that works in Python works in here. Plus, division, subtraction, modulus, multiplication, they all work the same here in C. So maybe do some, I don't know, 1 plus 1, then print it out. I don't know, just do some stuff. Make yourself comfortable with making some variables and printing things out. Tomorrow, we're going to go over input and if statements, elif statements and else statements. And we're going to make ourselves, we're going to remake games. We're going to remake games we made in Python in C. All right. So tomorrow we're going to go through the if statements. We're going to go over getting user input. And then we're going to go over remaking the games that we've made before. So I guess it would be our guessing game, I think is the first one we made. So we're going to remake our guessing game. All right. We're going to remake our guessing game. We're going to make it without randomness. Then we're going to make it with randomness. I don't know if we're going to introduce randomness, if we'll have enough time. We should, hopefully, for tomorrow. Why does it print line 17 and not just 7? Wait, why does it print 17 and not just 7? I don't know what that is in reference to, because I have no 7 or 17 here. So we're going to do that. So you'll see that be remade in C. Like I said, you learn one language, you know them all. The syntax is slightly different. If statements, elif statements, else statements work exactly the same as they do in Python, as they do in C. Slightly different syntax. All right, slightly different syntax. Getting input from the user in C is kind of the same, a little bit more cancerous, but it's kind of the same. And it's also more dangerous. In Python, they pretty much ensure you that things are going to be okay for the most part. In C, things can go bad for you very quick. All right. It's just as pretty much as easy as it is in Python. It's just the syntax is a little different and it's a little bit more annoying. All right. But the point is, it's the same. You can get input in Python. You can get input in C. All right. You can make variables in Python. You can make variables here. All right, etc. etc. I hope you guys see the recurring thing here. Int x equals 7. Says int x is equal to, I'm telling it, yes. Also remember, order is important. Yes. Remember, ordering is important. So make sure you're ordering things in the correct order, because it is also reading from top to bottom again. From top to bottom. But it prints 17. What I'm guessing is you didn't put a new line. Remember, you have to put your own new lines on every single line. It's not like Python where everything will be on a new line automatically. You got to do those /n's. You have to put your own new lines on every single line. All right, that's the issue you're running into. All right, that's all I got for you guys today. This code is going to be going into the supporters chat, full of comments. All right, full of comments. If I don't think I've said it all yet, but Patreon, Discord Premium members, both of them have access to events chat, which I'm in right now talking in. You can join in there and chat away. Additionally, at the end of most of these sessions, they'll get dropped the code that we have created with documentation attached to them. All right. So that way they can just get rolling on whatever extra stuff they didn't do, and they have documentation they can refer to. So if that's value of you and you like what we're doing, then you can support us on Discord Premium or Patreon today. All right. I will see you guys tomorrow on the next one.